I'd love to welcome Apostle up to talk about solar steam.
Hello, everyone. While everybody's making their way back to the front of the room, maybe I'll just share a quick story. How many of you have seen the Pixar movie Inside Out? Okay, there is quite a few people. So we have a 16-month-old daughter at home, and the day before I was leaving for the Twin Cities, actually, we started watching the movie, and it was a very interesting story about a family from Minnesota that had to relocate to San Francisco because the dad was pursuing a startup job. And it really got me thinking, why do always people have to relocate to San Francisco? And from everything I've seen so far from the Twin Cities, I don't think that there is any reason why anyone from Minnesota should be doing that. So hello again, my name is Apostle Radev. I'm the CEO and founder of Solar Steam. And what we do at Solar Steam is we use solar technology to generate heat. But it's a slightly different type of solar technology than what many of us are used to seeing. But before I tell you more about the technology, let's speak about why this is important. Our vision here at Solar Steam is to decarbonize some of the highest emitting and hardest to abate heavy industry segments. Depending on whose statistics you're looking at, heavy industry represents up to 1/3 of the global energy emissions, and up to 80% of that is in the form of heat. And the problem here is that since the Industrial Revolution, heat has been generated by burning fossil fuels, and in the process we release quite a bit of emissions, and we are also facing a scaling cost of procuring the fossil fuels. Now, our technology provides the same product, which is heat, but without the problem of cost, emissions, and intermittent supply, something that Europe is facing big time right now. What's novel about our technology? It's that we are introducing an enclosure component that helps shelter the system from the environmental elements. In Calgary, we are no strangers to minus 40 degrees Celsius, which is where Fahrenheit also meets. And our system is specifically designed for some of these cold climates where we can withstand wind loading, hail, and snow. And over the last winter, we actually demonstrated heat generation at minus 40 degrees Celsius as well. Our technology is patent pending. We actually just received our first patent 2 weeks ago. That's a US patent. And we have another 6 pending, and we are expanding across multiple jurisdictions with our IP portfolio. A lot of the novel principles behind the technology are based on what we call design for manufacturing, shipping, and assembly, or DFMSA. What that allows us to do is to approach the development of the technology in a modular fashion where everything is pre-built, IKEA-like or Lego-like, which allows us to ship fully pre-built modules to site and enable very quick deployment that doesn't require specialized trades. And one thing I forgot to mention, we integrate with thermal energy storage, and this is not something that we may or may not be doing. We've been doing it successfully for the last 2 years. And the range that we cover with our technology lately has been described in the market segment of solar heat for industrial process, or SHIP. And I've been told to be careful with how I pronounce that SHIP, because with my accent, my P sometimes sounds like a T, so it is a P there. But we have a couple of beachhead markets that we have identified after over 4 years of customer discovery. Industrial decarbonization, it's a very large market for us where we can tap into multiple different processes on the low and medium heat. And same goes to direct heating and cooling. And that's right, you heard me right. There is a cooling technology that needs heat, and there is a very big market for us there. And we've also have quite a bit of opportunities with the sustainable aviation fuels, or just green fuels in general. And the other market that I'm always very excited about is water treatment. And what makes us different than some of the other solar thermal technologies, which are highly geographic or project or application specific, is that we can capture that full range from as low as 50 degrees Celsius to as high as 40 degrees Celsius, or about 900 Fahrenheit. And for any applications that require temperatures higher than that, we can help get the heat halfway there. So that this is where we can offer a very stackable solution with other complementary heat generating technology. And what that means from how do we compare to the alternative solutions is we use levelized cost of heat as kind of a benchmark metric so that we can compare ourselves to others. And here on this slide, which is where we are using data from the International Energy Agency, we're demonstrating how we stack up against other technology with some other regions. So So we are quite competitive to heat pumps, and I don't have anything against heat pumps. Love them. We are looking to co-integrate with heat pumps. But even in regions such as the Midwest of the US, we are a lot more competitive than conventional solutions, some of the novel solutions with average levelized cost of heat, including thermal energy storage of $35 per megawatt hour, which is a metric that doesn't include any subsidies or rebates. And the way that translates to a total addressable market is that we are looking at over $1 trillion total addressable market. And we have a serviceable, obtainable market of close to $200 billion by 2050. And so far, we've had a stronger focus on Canada, which is where we're based out of. We have about $10 million in first-of-a-kind projects in our pipeline. We also have another pipeline sitting on the first project of another $70 to $80 million. And just in our province of Alberta and the nearby province of Saskatchewan, we have mapped out close to $500 million in projects. Canadian market is big, but as always, the US market is so much bigger. And we're very interested in finding the right place to make our market entry. And by 2050, we're also forecasting over 3.5 gigatons of cumulative CO2 offset. So how are we going to get there? So far, we have over $5 million in contracts that are sitting on an $80 million pipeline. And while I'm here in the beautiful Twin Cities, my team is actually finalizing a deployment with the federal government of Canada, which is for procurement. And the other project that we have been approved for is our first-of-a-kind project for industrial water treatment integration. And we also have had quite a bit of interest for various different players in the agricultural space on the Canadian side. And we've had quite a bit of interest for co-integration with green hydrogen, renewable natural gas deployment, as well as various types of water treatment projects across the US. And the team behind Solar's teams is led by myself in the CEO role. We have a domain expert as a chief technology officer, which is Robert Gard. We have a rockstar operator, Anna Byron, and we are further supported by four full-time employees, 2 part-time employees, and 6 industry members. We are currently, we just closed a seed 1 round, and we have a seed 2 round open, and we already have a term sheet. And that round is going to help us with enabling us to achieve some of the milestones that we have for the next 2 years, which include significantly reducing the cost of client acquisition, increasing our production capacity by at least 20%, really pursuing some of these new markets that we have identified, and finalizing our first-of-a-kind project. And with that, I would like to thank you for your time. My name is Aposto Radev, CEO of SolarSteam. And what we like to do at SolarSteam is to inspire people to see themselves standing in the future and being proud of what they have accomplished. I'm happy to open the floor for questions.
So if you haven't spent much time with me in the industry side, my favorite technology is solar thermal. And so I was so excited when Apostle and I met over a year ago to have him in the cohort here. So questions from the audience? Jamie?
We have a challenge in this climate of heating buildings when it gets super cold. Can you expand a little bit more about the ways in which your technology can help with that?
Absolutely. So the question was that in the local climate, there is a challenge with heating buildings and how we can help with that. So we can co-integrate with legacy equipment or existing equipment. So that will be a brownfield integration, where we're actually not asking anyone that owns the building to rip out the old equipment and replace it overnight. We are power engineers, like multiple members of my team, including myself, are power engineers. So we have a lot of respect for the operators. So we can understand what the legacy equipment is. And we have the ability to integrate in a modular fashion, where we can start with a smaller installation to help meet 2030 targets. And over time, we can increase the capacity to meet net zero targets by 2040 or 2050. And thermal energy storage, it's a very useful tool with bridging intermittency and the shoulder seasons.
Great. Other questions? Right here.
So you mentioned the lightweight construction, which helps presumably shorten down the install time. Can you give a little more sense of that? I mean, is that weeks? Is that months? A little more precision there, maybe.
Yeah, so the question is around the lightweighting the equipment and that DFMSA program that I mentioned, how that can enable quick deployment. So this is our first generation 5 megawatts module, which is what we call an Asterix. It took us probably 5 weeks to build. With the second generation one, the one that I was referring to that we were deploying in Ottawa, we were looking to build it in 2 days. So this is just an example, and then in time we're looking to get much better than that. So the enclosure really, it's allowing the lightweight equipment helps from a CapEx perspective, but it also helps with accessing new manufacturing channels that were previously not considered for this type of deployment, for this type of technology. Go ahead.
So what's, just looking at the picture, what's the use case here? Are you driving a boiler? Are you driving a turbine? How's it used?
Yeah. So the question is, what is the use case that we're demonstrating on the picture? So this is our R&D research development and demonstration project. So this is a closed loop system, and in the trunk, which you can quite see on the picture, is where we have the heat load dissipated by a fan coil. So what it allowed us to do is to recreate the behavior of different types of clients. And the way it works is that what you're seeing closer to, I guess, what's on the picture is the outlet. So we've demonstrated heat generation using water as well as the glycomics. So we have the heat transfer fluid coming in from the inlets of that tube, which is what is called a solar receiver, or in the eyes of the regulator, this is the boiler. And under the power of the sun, we can generate the heat exiting from the outlet. And the collector is tracking the sun from sunrise to sundown on a single axis tracking system.
Again, are you driving a turbine to generate electricity, or are you feeding this hot water or hot glycol into a boiler system? Or
So yeah, the question is, what are we doing with the heat? So we have the ability to do power generation by integrating with the steam turbine on ORC, organic cranking cycle. But most of the applications that we're after are direct heat supply for processes that need heat as part of their manufacturing.
Also, can you mention some of the industries or processes that fit well with that heat profile?
Yes, absolutely. So actually, here, where is my clicker? We can go back to one of the slides. There it is. Yeah, maybe I'll use water treatment as an example. So there is 2 main types of water treatment: multi-distillation effect that occurs on a distillation process, or reverse osmosis, which is membranes treating the water. In both processes, that they need heat. With multi-distillation effect, you need the heat so that you can separate the contaminants from the water. So this is where we can come in and supply that heat directly. And with the other process, which is reverse osmosis, you have sludge on the back end, and that sludge needs to be treated. Other maybe processes that we are more familiar with, something that we use in our daily lives, like the foods that we eat. There is a lot of heat that is needed for grain processing, which is a very big market that requires a lot of heat for a short period of time. And textiles, pulp and paper, cosmetics, dairy production, the various different types of beverages. These are all industries that need anywhere between 70 to 90% of their energy in the form of heat rather than electricity.
Time for maybe 1 or 2 more questions, depending on how complicated it is.
You're looking to raise, I think you're looking to raise $4.5 million.
4 million, yes. And we have a term sheet in place, and we're looking to finalize that by the end of the year.
How are you going to invest the capital?
How are we going to invest the capital? It's about half of it is for expanding the team, 70% on the business development side, 30% on technical development, and the rest of it is upfront cash for some of our projects, which can also be debt finance. Yeah, we'll do. And I think there was one more question here.
Can you explain a little bit how the system works in a cooling mode function?
So there is cooling technology that needs heat as part of the separation process, such as absorption or adsorption chillers. So we can provide, so instead of relying on the grid or on natural gas to generate that heat, we can generate that heat in a renewable fashion when cooling is needed the most, which is during the summer and during the day, and supply that heat for the coolers that needed to generate their cooling process. Happy to chat more about this. There is probably many hours of explanation that goes in there, but we're looking to refine how we explain the voodoo technology of using heat for cooling.
Voodoo is the technical term. Great. Other questions? All right, Apostle will be here. Oh, yeah, go ahead.
This might be a little technical, but How does the conversion factor relate to heat pumps, switching from this technology to using heat pump?
So the question is, how does the conversion factor work or compare? How does it compare? So capacity factor, it's anywhere between 30 to 40%. Efficiency, so that means when the sun is shining, it's anywhere between 70 to 90%. So we are very efficient, much more efficient in comparison to other heat generation technology or to other solar technology. Solar PV is 22, maybe 25, depending on the new research that is coming out, efficient at best. Well, thank you so much for this opportunity.
Good job. All right, wonderful. We're going to pivot from Calgary back to Minnesota, another Gopher Proud startup here with Seamus Kane coming up to start talking, enlighten you about ammonia's role in power generation. Super excited to have him with us today.
Thanks so much, Nina. So yeah, as Nina said, Seamus Kane, a PhD, founder and CEO of Aza Power Systems. I'm a Gopher Proud. Lived in Minnesota my whole life, and I'm going to talk to you a little bit today about ammonia and hydrous ammonia and how we can use that for power. Just like to harken back a little bit to Andrew Jones's presentation and CARBA. He mentioned that there are sort of two things we need to do with carbon. One is get it out of the air so it stops hurting the environment. And my company works on the other side of the equation where we're decarbonizing applications that already exist. So what we're trying to do with Aza Power is we're trying to address a market need where heavy energy users have difficulty electrifying. And so there are large industries that are very difficult to decarbonize, specifically marine, mining, agriculture. And the reason they're so difficult to decarbonize is basically the sheer amount of energy they use and or how remote they are relative to the grid. So if you could imagine an ocean-going vessel hauling cargo, that vessel has a difficult time converting to battery electric because their entire cargo load would need to be batteries in order to make it across the sea. So those are the applications that we're really looking at with our technology. And we have an opportunity to harness green hydrogen and green electricity in the form of green anhydrous ammonia and use that as a fuel to sort of propel ourselves to a greener future. So in the battle, really, there are a lot of different technologies that all need to come together to make this happen. And not to discount batteries, not to discount hydrogen, and like SAF and things like e-methanol. We need all of these things in order to make this transition happen. But what people aren't really aware of, or at least I don't think people are aware of, is that there is an alternative to green hydrogen that is a lot easier to store, and we already make a ton of it worldwide, and that is ammonia that is made from green hydrogen or green ammonia. And so there's a hierarchy that you need to follow. And if you have green electricity and can use it, great, use it. But if you can't, you need to turn it into a molecule you can use later. And that's where green hydrogen comes in. But hydrogen is difficult to pipe, it's difficult to transport, it's difficult to hang on to once it's in a tank. And so if you can't hang on to that hydrogen long enough to use it, you need to turn it into something else. And that thing should be green ammonia, because we are so good at making ammonia. It is the most made chemical worldwide of all chemicals that humankind makes. We make almost 200 million tons of ammonia per year. We don't make anything in that quantity at that scale worldwide. And so electrofuels are great, e-methanol is great, but I would like everybody to get a little bit excited about an alternative to hydrogen called green ammonia. And so what do we actually do, Aza Power? We've got this green ammonia, that's great. We're not making it. We want to use it. And what we want to do is enable the ability to use that as an energy source. We use it as a fertilizer right now. It's everywhere. We make a ton of it for fertilizer. It feeds half our planet. We want to basically unlock the market for its use as an energy vector so that we have a viable replacement for diesel fuel, for natural gas, for gasoline, for some of these things like hydrogen that are great, but we can't really put them into use because we don't know how to move them around. And so basically, we make it possible to use ammonia in your engine your gas turbine, your power plant, your thermal process where you're melting steel, where you're melting glass. We have a suite of technologies that come together and make that work. And make it work in a way that is environmentally benign and the emissions stay low and no carbon is emitted.
Can you make sure to all swallow the mic?
Sure. Is that a little better, guys? Yeah, sorry about that. It's really loud up here, so. But yeah, so just to give you a little taste of what we're working on replacing IC engines that run on diesel, run on natural gas, and run on gasoline, and repowering those to use clean, green, anhydrous ammonia. And so our very first product demo, thanks to Grid Catalyst and we're working with St. Thomas Center for Microgrid Research on, is a mobile electrical genset that can be used in a number of different applications, running on 100% clean, green, anhydrous ammonia, producing no CO2 emissions, and reducing its overall greenhouse gas intensity by 99.9%. It's not 100%, but it's very close to 100%. And we see multiple applications for this product, namely construction sites, oil fields, remote, islanded, basically microgrids, and hospitals, data centers. We talked about data centers a lot today. We see this as being something that a data center might buy, and many more. And basically what we do in our sort of proprietary process to make this work is we take existing engines, we can apply our technology to any existing engine, and we mainly use a suite of components that we can buy off the shelf or from aftermarket companies. But we use a proprietary pre-chamber ignition process in order to make this ammonia burn. And that gives us our benefit over our competitors, both OEMs and startups, who have not yet been able to burn ammonia efficiently in a manner that gets them that greenhouse gas reduction. So here's a little bit of a nitty-gritty on how it works. Basically, our process, what we're trying to do with ammonia and how we make ammonia work. The thing that doesn't work is putting ammonia in an engine, putting ammonia in a turbine. Doesn't work. You get horrible emissions, offsets any of the greenhouse gas benefits you might have had by removing the carbon. And so what we're trying to do is we're blending the way that a diesel engine and a gasoline engine work together into a sort of hybrid technology. And that hybrid technology is all about heat and speed. So what we're trying to do is get that ammonia really hot, really fast, and once we get that property, we can ignite the ammonia and it will burn basically in a rapid fashion, preventing any emission of ammonia, any emission of nitrogen oxides, and any emissions of N2O, which is where that 99.9% metric comes in. We emit a little bit of N2O, 1 to 2 ppm, but we still reduce our greenhouse gas footprint by 1,000-fold over our diesel competitors. And so basically we want to compare our technology here to the incumbent diesel and the incumbent proposed solution to diesel, which would be portable electric battery storage. And so to boil it down, compared to diesel, where we win on CO2 emissions, we win on equivalent usability. So the diesel genset and the ammonia genset operate the same way, produce the same amount of power. But where we win, our engines are quieter when we convert from diesel to ammonia. And we have a much longer maintenance cycle due to the non-acidic gases that are produced by burning ammonia as compared to diesel. And so instead of a 500-hour oil change interval, we have a 5,000-hour oil change interval just because of the intensity at which the combustion process damages the engine. So we win in that regard. We have lower maintenance cost. And if you compare fuel costs, if you take ammonia at market price of about $350 to $400 per ton, compare it to diesel at about $4 to $450 per gallon, we come out ahead after 2 to 3 years when you convert one of these engines from diesel to ammonia. Now, compared to battery electric, where we really win is in the power density aspect. We can hold anywhere from 7 to 10 times more energy on our genset when it's fully loaded with fuel as compared to a battery of the same weight. We can refuel it almost instantly, about as fast as refueling a diesel genset. You don't need to charge it up. And basically it's field reparable. So it operates very much the same as a diesel engine, same technology, just different fuel. So I don't need to dwell too long on our market applicability, but basically the 5 markets that we're trying to address with this technology are enormous. And what I want to emphasize is that the total addressable market for all 5 of these major sectors has huge dollar value behind it. And so really the challenge is getting this technology proven and getting it to these end users who might use ammonia in place of diesel. The other real benefit, and the one that's most exciting to me, is the CO2 benefit that we can enact by getting this technology into maritime, into locomotive, into mining. There's a huge amount of CO2 emitted due to just the use of diesel fuel in all of these sectors, and natural gas in the power and thermal generation sector. And if we are able to address even a small portion of this market in the next 5 or 10 years, we're able to basically reach gigascale carbon dioxide reduction across the board. And so the market applicability and the potential benefit from greenhouse gas perspective is huge. In terms of the way we're approaching this, we initially have a business model where we are offering conversion technologies modeled after one of the startups that we are closely following who does ethanol technologies. And we're using some of the same exact networking and metrics that they do to do their ethanol conversions. But what we want to really transition to is OEM partnerships with the manufacturers of the engines that we are converting right now. So we're talking about Caterpillar, we're talking about Cummins, we're talking about Solar Turbines, and many other manufacturers here, GE, Pratt & Whitney, et cetera. We want to get with these OEMs and partner with them so that they can provide an ammonia-powered genset or an ammonia-powered gas turbine using our technology. Right now, our team is lean. We're small but mighty. It basically consists of me, my co-founder and former PhD advisor, Will Northrup, and our business team, Tim Krebs and Anil Bika, bringing the business and the fundraising aspects to our company. And yeah, that's my company in a nutshell. And we're Aza Power. We're meeting your energy needs without the carbon. I'd like to answer any questions you might have. Thank you.
All right, starting back here, yeah.
So if someone were to compete gensets or vehicles or something like that, where do you anticipate them sourcing the ammonia from to support the use of the vehicles or the generator?
And
Yes.
Seamus, will you repeat the question?
Absolutely. Yeah, so the question is, where's the ammonia going to come from? And this is a question that I get asked all the time. So we're not making the ammonia. But what I want to emphasize is that there are ways to get gray ammonia today, high carbon ammonia. And the partners who provide this are basically the pipeline owners and their midstream partners, and then the end suppliers. End suppliers being like Airgas, midstream partners being the truckers and tankers that move between the pipeline, and then the pipeline owners like New Star, basically. And so there's a network for distributing ammonia today, but there isn't green ammonia necessarily. And so there's 2 things that are going to happen. You can start on gray and move to green as the ammonia supply becomes more green, or you can partner with small-scale distributed ammonia generation, which is an up-and-coming thing that the state of Minnesota is actually spearheading within their university departments to generate ways to distribute ammonia across the Midwest and across the farmland, where you can pick up certifiably green ammonia and use that for fertilizer, or in this case, for fuel.
If you can't get the green ammonia, what's the carbon savings look like?
Right. So basically, the question is, if you can't get green ammonia and you have to run on gray ammonia instead, what is the carbon stack up compared to the incumbent? And basically, it's a wash in this case. If you have to use gray ammonia, you are not getting the carbon benefit over running diesel in your genset. That said, it's a wash, so you're not losing necessarily, because the way gray ammonia is made is from natural gas, and natural gas is probably the lowest carbon footprint per megawatt hour of thermal energy released of all the fossil fuels. So compared to diesel, it's cleaner. Turning it into ammonia, it becomes a wash.
So you mentioned it takes time and heat, indicating that it takes a lot more heat than maybe a traditional ICE. Is there any danger to that, to needing more heat to convert the ammonia and use it to power things?
So the question was, is there any danger or risk in applying more heat than a standard IC engine in order to make the ammonia burn? And the answer to that is it depends, but largely no. Where we're applying the heat is actually in the compression process on the engine, and this is where that hybrid between the two combustion modes comes in. We're heating the air and heating the ammonia when it goes in to safe and normal engine temperatures, but then we're compressing it a lot more than a gasoline engine might do, and that's where we're getting a multiplicative effect of the heat. We go from 80 degrees Celsius up to 600, 700, 800 degrees Celsius before we ignite. And the heat is generated by the compression. It's so fast that the heat doesn't have anywhere to go except into the work extraction process in the engine.
What kind of feedback are you getting from these carbon-intensive industries about these motors? Say, you can speak about one or all of them, say maritime or industry.
Right, yeah, and so maritime's really where all eyes are right now when it comes to ammonia due to the IMO 2050 mandate. Basically, they have to be carbon neutral by 2050 in maritime, and all shipping industries are part of the IMO, and so they have to find something. So there is a lot of intense debate as to whether or not ammonia can fill that need, but there are maritime companies that are building ammonia ocean-going vessels today already. So they're for it, but at the smaller scale, that's where you started to run in a little bit of pushback. I've received mixed interest from engine OEMs on this, and largely the feedback is, I know this is coming, but you're 5 or 10 years early, which we want to use to our advantage and position ourselves as industry leaders in this technology when they decide that we are no longer early and it's time for ammonia.
Can this engine run on other kinds of fuels?
Yes, so basically our version 1.0 that we're planning to demonstrate this year, it can run on other fuels. It runs best on ammonia. It does not run on diesel anymore after it is converted, but it can run on other spark-ignited fuels such as natural gas or gasoline at a hit to efficiency. Methanol, yes, methanol is also an option and it can run on methanol, yes. But the demonstration model that we're deploying will not demonstrate those other fuels. That's something that we're kind of working on in our Skunk Works department.
What's the maritime industry doing for the conversion of ammonia for shipping?
One more time.
What are the shipbuilders using for their power conversion?
Okay, the question is what is maritime doing in order to incorporate ammonia into their fuel stream? Yes, so the reason that maritime is going first is because of the sheer scale at which their engines are. They basically run anywhere from 8 to 14 cylinder inline engines as their prime movers, where the pistons are 1 to 6 meters in diameter. They are absolutely enormous engines. They redline at 100 RPM. That's full steam ahead. And so what they're doing is they're doing what we can't at our scale. They are just putting ammonia into the intake tract, and then they are burning it with a tiny amount of diesel. This is where I got my start as a PhD student 9 years ago at the University of Minnesota, was putting ammonia into the intake and seeing what happens. And the bigger you go, the better this works. But besides maritime, most engines are smaller than that, and they require a little bit more technology in order to make them efficient and low emissions.
Is there any risk to, like, with IP that the OEMs own and tinkering with the engines and then potentially intervening and preventing that from happening?
So the question is there any risk to the IP with regards to OEMs? You're basically concerned that OEMs can sidestep our IP and do this independently, is that correct?
In converting, they would prevent customers from doing that conversion as a result of the IP that they own. I mean, John Deere and other big companies are notorious for this.
Gotcha, yeah. So basically the idea here being that John Deere would say, you know, if you're a customer and you use Aza Power's conversion technologies, we will not sell to you, we will not work on this engine, et cetera. And there is a real danger there, and that's why we're working so hard to foster relationships with Deere, with Cummins, with Caterpillar, all the engine OEMs, Toyota, We've talked with Toyota. Toyota's big on ammonia, if you guys are not aware. But yeah, that's a very big danger, and they could always say, yeah, please go ahead and do that, and then pull back and renege on that deal whenever they want. But that's a risk that we're going to have to shoulder.
It's time for one more question. Edward.
Your resident question asker here. What is the pipeline for green ammonia, at least in the state of Minnesota? Where's it at? Where's it go?
So the question is, where's the pipeline for green ammonia in Minnesota? Where are we headed with that? And to that, I'm looking largely to the new hydrogen hub, the Heartland hub. The hydrogen that we're going to make from green electrons here in the Midwest is largely going to be making fertilizer, whether or not those hydrogen electrolyzer companies know it or not. But we are also at the terminus of the ammonia pipeline coming up from the Gulf and are connected to the big ammonia producers down in Louisiana and south of here. And so green ammonia started here. Green ammonia actually got its start. University of Minnesota Morris built the world's first green ammonia plant in the world. And so we're big on ammonia here, and we want to foster a circular economy where we're building electrolyzers, green hydrogen, producing green ammonia for export here in Minnesota, and then also pioneering the energy technologies to consume it elsewhere.
I learn something new every time I hear Seamus present. Fantastic. All right, our last 2024 startup presentation for the day. Before Cam comes up, I just want to ask a quick question. How many of you have ever worked within a couple of degrees of a construction project as a utility, on development, hands high in the air? All right, so at least half the room knows the pain point of trying to figure out what is under the ground. It is one of the most difficult prospects. Having worked for a district heating and cooling company, it was the bane of our existence because no information was ever correct about what they would tell you was under any square foot of downtown St. Paul. So when I met Cam and saw the technology he was working on, I was like, please come save us. This is incredible innovation, and he's gonna come up and tell you all about it.
Hi everyone, Cam Raufi. I'm the founder and CEO of Prezerv. At Prezerv, we are creating a 3D Google map of the underground. The journey for me started when I started my PhD at Purdue. I spent 6 years developing material sensing technologies, and after that, I started working for Bechtel in the construction world, and later on Eversource Energy in Boston, and realized a number of inefficiencies in underground construction. And that motivated me to change my career path, pursue entrepreneurship, and start Prezerv in 2021. Sorry. All right. At Prezerv, our mission is to accelerate the modernization of physical infrastructure through accurate underground geospatial solutions. So we are a small team. We are about 3.5 years old. And besides me, Mustafa, our CTO, has 7 years of experience in machine learning and AI. And Yuri, our chief scientist, has 35 years of developing autonomous geospatial solutions for defense and aerospace industry. And Sam is our legal and business advisor. All right, so now that we talked about the team, let's talk about what we do. As most of you know, construction runs late and finishes over the budget. And one of the primary root causes of this issue is that contractors don't know where underground utilities are when they start digging. The inaccurate underground mapping problem delays infrastructure projects by an average of about 20%, and it also causes more than 500,000 accidents a year in the US alone. causing $30 billion in damages, and also 400 fatalities, a lot more injuries, and also adds substantial amount of CO2 to the global CO2 emission. So you may ask what contractors are using for maps today. Most use inaccurate, outdated historical records. As an example, I use this map from 1898 in one of my projects in Boston. The accuracy is 40 feet, although this is very poor accuracy. It's not unusual. At least in this case, we had a map. And a lot of cases, you know, when utilities are handed over or the old PDF files were stored in a field office, it got flooded and it was lost forever. So the other big issue is that these maps are two-dimensional. They lack the critical depth information. So imagine you want to build a new line at the intersection, lines crossing on both sides, and you really don't have any clarity on where the pipes are and what kind of clearance you have. So contractors, being in the dark, they start digging some random holes, searching for pipes, and this whole process is manual, ineffective, and also expensive. So based on my professional experience, 12 years working in the field, and 2 years of customer interviews we've done across the country, we realized that the number one priority for customers are on-time project delivery. And they simply look for tools and processes that help them achieve this goal. At Prezerv, we are focused on creating automated 3D digital twin of the underground to help them achieve this priority. And how do we do it? We use data from top-tier, commercially available phase array radar scanners. This is a picture of the unit we use in our operation. Inside that yellow box, there are 24 sensors scanning the ground at 1-inch intervals. And at every inch, they send 300 frequencies underground. 1 hour of operation of this device at 70 miles per hour creates about 570 million electromagnetic images, as you see here, which is abstract and non-intuitive. This creates basically the bottleneck for this technology, just not having enough experts in the field to analyze that volume of data. And that is why over the past 3 years, we spent a lot of time developing an AI algorithm that will go through that electromagnetic image, the 3D electromagnetic image, and automatically creates a 3D model of the underground utilities. And we place them on the map where they belong with inch accuracies. And once the maps are created, customers can go to our website and view the data with a few clicks, or see the data on their iPhone with an augmented reality application. And we help customers avoid their project delay by enhancing construction productivity, especially the underground construction productivity, by about 15%. We can also provide the maps 100 times faster. We are very efficient at mapping miles and miles of roads and acres of lands. There is no other technology that can map such a large areas in the time that we provide, in a timely manner that to match our timeline. We also help customers avoid accidents and fatalities. And that's also costs, every accident on average costs about $60,000. And we charge less for that, the whole mapping process. So in terms of the competition, we can divide the competition into two categories, those focused on accuracy and those focused on delivery speed. On the vertical axis, you've got the 3D accurate data on the top and the 2D historical records at the bottom. On the horizontal axis, you have the hardware-focused solutions on the left and fast AI solutions on the right. Most customers use maps from surveying companies. Their product is outdated and old. The next group are hardware companies. They are big on hardware and low on automation. And the next group is the software company that are basically visualizing the old inaccurate record. And right now there is a gap between where we are and the rest of the market. And I would also point out that the other big players in geospatial market, they are focused on the above ground, and underground is our golden niche opportunity. So let's look at our impact. So this table compares some of the key performance metrics between us and available techniques, such as GPR and vacuum excavation and historical records. We are the only solution in the market that can provide accurate maps 100 times faster than the other methods. And that would help our customers reduce their risk of their project delay and project cost overruns. I would also point out that techniques such as GPR, not only it takes a while and it's manual, it also doesn't work because they scan the ground at large frequencies in one wave frequency, which only show them a fraction of the data that we are providing to the customer. The other alternative is vacuum excavation. It's very expensive and it's very slow. Once you are waiting for that data, you cannot perform construction. So we have a SaaS business model. We charge customers annual subscription fee, and they pay for the maps that we create for them. Our target market is about $17 billion, and it's global. I always say, if you think we have poor maps, most of the rest of the world, they don't have any maps. So I think that creates a substantial opportunity for us. And our target customer right now are utilities and energy projects and the service providers in these markets. We started in 2021, and we have started our pilots earlier this year, and we've got more than 10 paid pilots in the pipeline. I would love to talk to you about the potential pilot projects so you could evaluate our products and give me feedback. And my goal is to turn some of these pilots into long-term commercial contracts. And in Minneapolis, we are excited to be working with Evergreen Energy. And we have few projects that are on the pipeline. And So my goal is to make it very simple. First, you would go to our website, on our platform, define your projects, create a map request. Then we have the area scanned, and once the scans is complete, we quickly create the maps that you could see on our website or on an augmented reality application. Here is one of the projects that we did earlier this year. This is an old utility substation that is 120 years old in Massachusetts. And they basically did not have any map of the underground. And the contractor was required to hand dig the entire construction site. They called us in, and we showed up next day. We scanned the entire construction zone in 1 hour and provided them the map. And after that, they spent 7 days with a vacuum excavation, exposing a small fraction of the areas we mapped in 1 hour. And when they were happy, they did the construction with a machine excavated most of the site and with no accidents. So that was a substantial improvement to their productivity. And the other project that I'd like to share with you is a college campus right outside Boston. for the first phase that you see here, we scanned about 1 acre of the parking lot. They wanted to install solar canopies and run the lines underground to the control room. They did not want to damage any of the existing infrastructure, buried infrastructure. So we were able to map out the entire parking lot and provide them with an accurate maps and also show them what was not on the map. That included a number of pipes and also infiltration chambers that was actually conflicting the design they had. So they are very happy with our solution, and they just asked us to map out the rest of the campus. So I scanned 34 acres of the campus in 1 day and with a UTV. So that worked out very well. And we are also working with them on adding additional capabilities such as leak detections for them. And we are also excited about our climate impact. By making construction more efficient, we think that we could reduce the carbon footprint of construction by 60 million tons annually. Also by adding additional capabilities such as leak detections and also providing integrated 3D map for asset owners and operators and cities, we think that we could enhance the resiliency and equity of our infrastructure. So thank you for your attention. We also have an open seat round, so if there is any investors in the crowd, feel free to reach me. Thank you.
We've got a few minutes for questions for Cam, and then we're going to pivot into talking about not only how to fund Cam, but how to fund all the other great innovators that we've got in the ecosystem. So questions? Cam, sure. I can't help it. I looked directly at you before I even looked over here. We're going to take this one.
Yeah. Is your model trained only to find infrastructure, or does it find other outlying things like culturally sensitive sites that may have artifacts or anything like that?
We can find everything, and we are basically converting the signals into point clouds. And then, as we develop more our application more, the more of these objects gets classified into different objects. So right now we have automated the classification of the pipes and other utility infrastructure. But I would say if there is a surface underground, we can see it and we can show it to you. We go up to 15, 20 feet right now, but I haven't tested any deeper. I think most of the infrastructure are the top 10, 15 feet. So, but if there is an application deeper than that, I think we could discuss that.
Yeah, I think we had one back here. Charlotte, did you have a question?
I actually was just going to ask, what are your current, what's the competitive landscape looking like? Because I believe there's some competitors already in the market. You did mention like the old, kind of old-fashioned way of doing things, but have you also done your research on current competitors and what that landscape looks like?
Right. Having been working in this area for the past, I would say, 10 years, I've seen a lot of claims. And a lot of people have tried to do it. But I think what makes this a lot challenging is that we are scanning the ground from one angle, from the surface, without knowing any idea of how the underground looks like. I think if you compare it to medical imaging, where you could scan all around the body, or the radar scanning for military, that is, through the air, very uniform. This is by far the most challenging one. And the technology needs to be, needs to work and scale through different soil conditions. And there are not many people can solve that problem. There is, I think there is another company that right now market their solutions, and to overcome what we are doing with one equipment, one pass at 50 miles per hour, they are trying to combine and fuse 4 different sensors: acoustic, seismic, electric, and electromagnetic. So most of these sensors require touching the ground and denoising. And using 4 different sensors and combining them, that's a very ambitious plan. And yeah, I haven't seen a third-party verification of their technology, but I'm very happy about what we do and the speed that we provide the mapping for. We are the only non-contact solution in the market that can map the ground at 70 miles per hour. And as far as I know, there is no other solutions that does that.
Yes. There was, Pat, you had a question?
Do you need an unobstructed surface landscape in which to work?
Unobstructed in terms of we could go around the trees, but I need to have a surface that I can run the scanner. It doesn't need to be smooth. I just need to be able to move the scanner.
And does the scanner need to be pulled by a truck?
No, it could be pulled. I pull it sometimes, like in the substation. I just did it. I walked the scanner. We could do a UTV, like a Polaris machine can carry it, or a truck. Or you could install it on a mechanical arm and scan the walls or the ceiling, look for defects. So I didn't cover those cases today, but there are other ways that we could use the technology. Sure. Yes?
If you start to concentrate enough samples in a single location, are you able to then use machine learning and AI to start to actually predict what's below without actually having to take physical samples?
Yeah, you are asking about the soil characterization of. Yeah, I think we would still require some sort of knowledge of the underground. Suppose if we know this is a sandy soil with, let's say, 20% clay, then having known that knowledge, we can scan the area, create a 3D volume of that soil, and then if there is variation within that, we could assume that it's water, and then tell you how much water you have. So we can create a map, but we also still need to go finer we need to have some prior knowledge. So, and what makes it exciting is that instead of doing 10 boreholes, you could only do 1 and get a lot more knowledge. So.
Thanks, Cam.
Thank you, everyone.
So as you can see, we have an incredible lineup in the 2024 cohort, thanks to the Innovators Network and our funding from Minnesota Energy Alley for making those partnerships possible. They run such a wide gamut of tech. If you haven't already, you should also check out our 9 finalists that pitch tomorrow. Some of them are here today. Just really exciting to have such a wide range of expertise and emerging technologies. So we're gonna pivot from the deep dive into the tech to the deep dive into the money. Because it turns out, you've probably heard this a few times today, that's one of the enabling factors to how we do this. It's one of the things we hear from startups is the hardest thing is finding, you hear all about the money that's out there, but actually figuring out the right fit and how to make that happen for your business, which is a good segue into introducing our moderator for today, Jeremy Kalin with Avisen Legal. Who gets a big round of applause, yeah. And if you came into this room not knowing who Jeremy is, I'm so glad you get to leave knowing him. You heard Dr. Pete Wyckoff mention this morning that where we are going next with the next, what's going to remain out of the federal funding is the tax credits. And Jeremy and his team at Avisen are the smartest people around, knowing how to make sure that that actually is there to deploy all the tech that we're bringing to the marketplace. So talk to him after that, after the panel. But now I'm gonna hand over the mic and put him in charge.